Hello guys, so in this video you will look at the working answer, some explanation about the worksheet that you might be answering, or maybe you would have already answered it. So it's about congruent triangles, and this is a short story you would have read from the past. And in present time, congruent triangles are actually used for having a better and strong construction, so that they can still hold those strong winds or heavy loads. So let's learn more about it. And here are some examples. For example, this one you would have already learned. There are these four properties that are used to prove whether the two triangles are congruent or not. That is side 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 test, or side 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 property. Then side angle side, angle angle side, and this R stand for right angle, then the hypotenuse, and one of the known side between two triangles. So if you can prove for the given reason, or for any reason, that there are these three minimum information that are valid in any given two triangles, so we can always say those two triangles are always congruent to each other. That means the other three parts of the triangles will definitely be equal to each other, the corresponding triangle. So how exactly we do that? We just use the given information from the question. For example, in this one, when we have to prove that triangle PQR and triangle ABC, we just have to list down what is given here. So in this case, you see those symbols, this and this in AB. It means the side AB is equal to side PQ. So let's write that here. Side PQ is equal to side AB. And the reason for that, in this case, it's already given in the question. So I'll just write given. Similarly, you can see that QR is equal to BC. Okay, and then PR, if you want, you can write PR or RP. So let me write PR, that's equal to AC. Okay, even for these two, in this case, it's given. All right, now once you have those three informations, we can say therefore the triangle PQR is congruent. This is the symbol for congruency. With So triangle PQR is congruent to triangle ABC. By which property? In this case, it's side 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 property. So let me write everything here. Property. Now this also says also name the other three pairs of equal measurements. Now it means we already have three sides, three pairs of sides. That means the remaining in this case will be angle P is equal to angle A. The order matters. So when you write this congruent statement, it must follow the correct order, with P with A, Q with B, and R with C, the corresponding angles. So then angle Q is equal to angle B, and angle R is equal to angle C. You can actually see that the order from here: angle P, angle A, angle Q, angle B, and angle R, angle C. So with that, um, let's see the next one now. So here there is another example. You can see this part here is a right angle triangle. There are two right angle triangles. So in this case, we again list down three informations that are equal and the reason for them being equal. So for example, angle ABC in this case is equal to angle PQR. The reason, they are 90 degrees right angles. So that's the reason here. AC equals to PR, they are equal in distance or length, which is already given in the question, and BC equals to QR, also given. There's another reason here that we can look at that AC and PR, they are actually the hypotenuse of two triangles. And then BC and RQ or QR, they are the other corresponding sides which are equal. So in this case, it's not side 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 because there is one angle involved. So there is SAS, but we are not going to write that because this is actually right angle triangle right angle triangles here. So we are going to write using this property RHS. So any one of the pair. And hence the other three congruent or equal measurements will be angle A equals to angle P, angle C equals to angle R, and then the other side, side AB is equal to side PQ. So that's your AB and PQ. Okay, so let's see the next one now. Here's another question where you can see we have been given that LM, this LM is equal to HP, and angle L, which can be written as angle MLN equals to angle HPN, which is written here in this part. It's given, and then for the third info, there's no third information given. So what we do is we are looking at the, what you learn in maybe primary P5, P6, or maybe sec 1. So this is the part here, this part of the angle, they are vertically opposite angles. So that's what we write in here, that L and M equals to P and H. They are vertically opposite angles, and that's the reason we can say they are always equal. And therefore, in this case, we have angle side property that can prove that these two triangles will be congruent to each other. And then the remaining three pairs of equal measurements are these. So the another angle, once these two triangles are equal, so this angle will be equals to this angle here, and the remaining other two sides, Ln equals to Pn and Mn equals to Hn. You can also look at the pattern here, Ln equals to Pn. So you can get the information from here or from the diagram. Okay, let's look at the next one now. Again, in this question, we have the two sides given equal, AG equals to GC and BG equals to DG, and vertically opposite angle as AGB equals to, you can say, GCGD. So in this case, it's side, angle, side property, and the other three pairs of equal measurement will be AB, which is this was not given, but once you prove they are equal, those two triangles are equal, you can just say that AB is equal to CD. And then the other two angles also, angle A will be equals to angle C, and angle B equals to angle D. Do not write angle A equals to angle D. That won't be correct. Look at the pattern here. A is equal to C, the corresponding. This part, A is equal to C, G is equal to, of course, G, and then B is equal to D. All right. So now here is another question where there is a river, and we are supposed to, you would have read the question. It says, by measuring the distance CE, he will be able to know the width AB. So, and we have to give the region. So all we can do is take these two triangles and we just prove them they are congruent to each other by one of those properties. So let's look at this. Angle A and angle C here and here, they are 90 degrees. Then what else do we have here? In this case, AD is equal to DC because D is the midpoint. It's already stated in the question. Okay, D is the midpoint. And then angle ADB and angle ADC will be equal to each other because they are vertically opposite angles. We cannot directly say that BD will be equals to DE and use the RHS property because we are not sure about this distance. But we have the property, so if we can use those properties, we can just say these two triangles are equal. So this is what we did here. Both 90 degrees, D is the midpoint for these two being equal, and this is vertically opposite angle. And you can say this looks like angle side angle property. So if I write that as angle side angle, sorry, okay, if I write this as angle side angle, here again property, you would notice that in your textbook they don't have this property. That's because this is same as angle side property, because if you know that these in two triangles, if you know that this is equal to this and this angle is equal to this angle, it means it's easy to say that the third angle will be equal to this angle. They will have the same measurement. So basically, if you whenever you come across a angle side angle property, that's nothing but similar to or equivalent to angle side property. So if you say this, we can say this is angle, this angle, this angle, and this side. So that angle, and this side, they are equal to each other. So we got BAD is congruent to ECD. And once you have this, you can always say any, the remaining three. So from those three, all we need to say that the side AB will be congruent to or equal to side EC. And that's the answer for Y part here, why it will be equal. So by proving, all you have to do is prove that those two triangles are equal or congruent. Once two triangles are proven they are congruent, you can just state the other corresponding sides or angles, they will be always equal. So that's the answer for this part. And here is the next one. Some of the working is already done here and the remaining is some is still left. So what do we do in this case? They say prove that PQ is perpendicular bisector of AB. So what do we have to prove is this PQ here will be perpendicular bisector. When they say perpendicular bisector, we have to prove that this is 90 degrees and this is equal to this. This is what we have to prove. AR is equal to BR. So let me write that here. To prove that, first thing, AR is equal to let me write BR, and the second thing we have to prove is angle R there. So that's perpendicular, right? So let's say one of the angle, let me just write angle ARP is equal to 90 degrees. That will also be equal to angle BRP. Okay, this is what we have to prove in this case. So to prove that, we will have to consider different triangles in this case. So first I have taken, you can see triangle APB and AQB. Why did I do that? APB, that's here APB, and AQB. To prove these two cases, we have to consider these two triangles, triangle APR and triangle BPR. So in that case, we don't really know yet anything. Yeah, they haven't given that what is whether they are equal or this is we have to prove. So we don't know anything about this yet. But what we can do is we'll take the different triangles like APB, AQB. So let's look at that triangle APB and triangle AQB. In this case, I have written AP is equal to AQ. Why is that equal? AP equals to AQ. Because you have to go back to your set one about the geometrical construction. How do you construct a perpendicular bisector? So what you do is you make the arc here and then make the arc here. With the same distance, you make arc here and make arc here. So what's happening there is these sides, by with the help of the geometrical construction, they will be always equal to each other. So that's why we have AP equals to AQ, and similarly PB equals to QB. All right, and then AB is equal to AB because that's a common side between two triangles. So you can say APB is equal to AQB by side test. And now you can say angle PAB, which is this angle here, PAB is equal to PBA, which can be written as, instead of B, I'm just writing it up to R, which is still the same angle, using it as number one. Similarly, you look at the triangle APQ, which is here APQ and BPQ. All the sides are same region here. Again, so by side property, they will be congruent. And now you can say that angle APR will be equals to angle BPR. So which is this angle here, APR and BPR. And now we use triangle APR and triangle BPR. So in that case, now when you look at triangle APR, which is this part, and BPR, which is this part. So in those two triangles, we have, okay, so you can see that angle A, this angle is equal to angle P. This angle A is equal to angle B. That's from equation 1. And angle P is equal to angle P, I mean, angle APR is equal to angle BPR from equation 2, which is this and this here. And then they have one common side. So PR is equal to PR. And then you can say by by angle side property, these two triangles are congruent. And once that's done, you can state that the AR is equal to BR, the corresponding sides of these two triangles, and these two angles are equal. Now also they are on one straight line. So if they are equal, their sum will be 180 degrees. So each angle will be 90 degrees, and hence it's proven. All right. So okay, somehow the writing part is not working. All right. So that's it, guys. I hope you understand. Thank you for watching.